Soil and Water Conservation Engineering Unit 2, which deals with MUSLE and RUSLE, which means Modified USLE Equation and Revised USLE Equation. A soil erosion modeling is able to deal with many of the complex interactions that control erosion rate by stimulating erosion in watershed. Specialists have created many precise methods that estimate soil loss and discover area where conservation measures will have the best drive on the reducing soil loss for soil erosion assessment. In MUSLE, model concept semi-empirical, statistical, empirical, physical deterministic. In Universal Soil Loss Equation, Weisman and Smith 1978 has discovered this USLE equation is an experimental method based on comprehensive information from the USA. This equation is basically designed and commonly used to predict average annual soil loss USLE. In 1977, Williams and Burnett built up the modified universal soil loss equation. It is a changed version of universal soil loss equation, while USLE derives sediment yield based on precipitation, whereas in MUSLE conclude it by utilizing runoff factor, which performs the antecedent soil water content. This alteration permits the utilization of USLE for predicting sediment loss on a storm event premises. MUSLE. RUSLE is an equation that estimates average annual soil loss by sheet and drill erosion on those portions of landscape profiles where erosions but not deposition is occurring. It is the upgraded equations of USLE as RUSLE. Comparison. It estimates the average annual loss from an area. It uses rainfall erosivity factor generated from annual rainfall data. It replaces the rainfall erosivity factor with the runoff factor. It estimates event-wise soil loss in MUSLE. It is similar as USLE, but the factors were upgraded with a higher accuracy. RUSLE upgraded the RUSLE a great expanded erosivity map, expanded information on soil erodibility, a slope length factor that varies with the soil susceptibility to the erosion, a nearly linear slope steepness relationship that reduces computed soil loss values for very steep slope, a subfactor method for computing values for the cover management factor. Next one, improved factor value for the effects of contouring, terracing, sloping management practices for rangelands. Next, need for remote sensing and GIS in RUSLE modeling. One of the major drawbacks in the application of erosion model is the low availability of input data. The conventional method proved to be too costly and time consuming for generating this input data. With the advent of remote sensing technology, deriving the spatial information and input parameters has more handy and cost effective. Multi-temporal satellite image provides valuable information related to seasonal land use dynamics, erosional features such as gullies, rainfall, interception by vegetation cover factors. RUSLE equation. RUSLE equation, which means the A is spatial average soil loss, or rainfall erosivity factor, K soil erodibility factor, L is soil length and steepness factor, C cover administrative factor, P support practice factor. Whereas in R factor defines, it quantifies the effect of rainfall impact and also reflects the amount. In K factor, it refers to inherent susceptibility of soil to erosion by runoff and rainwater. It depends on physical properties such as particle size, distribution, organic matter, soil structure, permeability. In LS factors defines the ratio of soil loss per unit area from a field slope to that from a 22.33 meter length of uniform 9% slope under otherwise in identical condition. In LS factor open for GIS interference, add DEM, layer fill, R toolbox, spatial analysis tool, hydrology, fill flow direction, flow accumulation, slope LS factor, spatial analysis tool, map algebra. In C factor is one of the most important erosion factor that can most easily be influenced by human to reduce erosion. Defined as the ratio of soil loss under specific cropping condition to soil loss occurring in the bare soil. P factor defines the ratio of soil loss with the specific support practice to the corresponding loss with upslope and downslope cultivation. Value approaching to 0 indicates good conservation practices, and value approaching to 1 indicates poor conservation practices. And by concluding this, the use of this technique to improve soil loss can be more authenticate and reliable with high resolution spatial data. The powerful spatial processing capabilities of this and its capability with remote sensing data have made the soil erosion modeling approaches more comprehensive and robust. Thank you.